Okay, we're here at gotomath.com working some calculus. Let's go down to differentials, and we are doing, looks like 3-1. Okay, things got a little crazy there. Round answer 4 decimal places. It says use differentials to approximate. So here's an application for differentials. We're going to approximate 1.6, taking the square root of 1.6. Now, if you're wondering what this picture is all about, okay, I'll tell you. First off, this green line, okay, the curve, this is actually f of x is equal to the square root of x. So this would be, just the square root of x, okay, the graph of the square root of x. Now this right here is actually the tangent line to the point 1.6, okay? At the point 1.6, this is the tangent line at 1.6. And you could use these tangent lines right here for linear approximations. We can linearly approximate if we plugged 1.6 into, let's say, mx plus b, plugged 1.6 in for x, and then got our y value out. This would be approximately whatever the square root of 1.6 is. But it's good only, right, if you're kind of close. If you're kind of close here, right around this area, okay, we can do an approximation, right, a linear approximation. So you'd have to derive up the equation to this line, but that's easy because you're given the function, so you can find the slope of the line, and then you can figure out what the actual point is here. But let's see, the square root of 1.6. What we want to do here is well, we'll go in here and write this down. So let's say, for example, I'm going to write it like this. F of 1.6. That's 1.6. Yes. Whoops. Okay, is equal to the square root of 1.6. So what's going on here is we have f of x is equal to the square root of x. Okay? And we're just plugging 1.6 in, but we want to know what this value is, let's say, without having to use a calculator. Okay, let's say that's what we're trying to do. Okay, now let's go back and write up some things that we've already talked about. For example, finding the change in y is delta x minus f of x is equal to delta y. So remember, we wrote this in 1-1. We did this in some earlier sections also, right? Finding the derivative by the definition, remember? Okay, so we're gonna use this right here, and also, so some things that we've already written down. We know that the change in x is equal to the differential of x, and that the change in y is going to be approximately the differential in y. Okay, these two are approximately equal to each other when delta x, when this guy is fairly small. Okay, when this is fairly small, these two are approximately equal to each other. All right, so if delta y is approximately dy, then what I could write here is that approximately, I can change this equal sign to an approximate sign and write dy here, and then continue to write f of x plus delta x minus f of x. Alright, now remember, we're going to try to figure out what this is and pretty much do it by hand. Okay, so now what I'm going to do is I'm going to break this up. For example, x is going to be equal to 1 and delta x will be equal to 0.6. You see that? Alright, so f of 1 plus, and then delta x is 0.6, minus f of 1 is approximately dy. Is approximately dy. Okay. Now what I'm going to do is I'll just go ahead and join both these together here. So f of 1.6, see that, is going to be approximately, because we're going to approximate this, is approximately, and then what I'm going to do is I'm going to take this and move it over to the right. F of 1, alright, plus dy. F of 1 plus dy. Now the question is, what is dy? Well, that means that we need to take the derivative of this guy right here. So I'm going to rewrite this in this form right here. Y is equal to x to the half. Okay, and then take the derivative. We have dy is equal to, bring the half out front, and actually I'm going to skip some steps here. Hopefully you can figure that out. Right, I just took the derivative, brought it down into the back down into the denominator, because this would be a negative a half, and then went ahead and rewrote the square root. So there's our dy. So we can replace the dy now with that. And also, I'm just going to go ahead and plug the 1 in right here. Okay, f of 1, so this is going to be the square root of 1. Is that cool? Plus, and then my dy is equal to this. And I'm going to go ahead and plug in my 1 into there also. Let's just do that also, okay? And then dx, remember what dx is. Remember dx is equal to delta x, but delta x is equal to 0.6. Right, 0.6, okay? And so the square root of 1 is just 1. And then this becomes 1/2 plus 1/2. And this right here is going to become 6 over 10. 6 over 10, so this actually reduces down to 1 plus 6 over 10. What do we got? We got 2 goes into 6 3 times, and so that'd be 3/5, right? And then 5 times 2 is 10, so 3/10. I get that right? I hope I didn't mess that up. Let's see, 2 goes into 6 3 times, 2 goes into 10 5, 2 times 5 is 10, right? 1 plus 3/10, and you know what 1 plus 3/10 is? 1.3. Okay, so we end up with 1.3. We don't have to round. We don't have to do any rounding. Now you notice that we did this by hand without a calculator, right? Okay, let's just scroll up the screen here. Let's remember the square root of 1.6. So the square root of 1.6, and of course this is approximately, because I'm going to be rounding to 4 decimal places or something like that. But if we actually did the square root of 1.6 and we plugged that into a calculator and looked at the decimal representation, there is an exact value actually. We end up with 1.2649, let's say. We'll go out that far. So as you can see here, okay, these are both approximately, I mean, they're fairly close. It depends on what you're doing, right? Depends on what you're doing. Sending rockets into outer space, that may not be close enough. But anyway, so this is quite interesting on how to figure that out. Let's go back to the web page and see what happens here on that deal. What did we get? I forgot. 1.3. I'm like scrolling up the screen real slow because I'm like, oh god, I hope that's the right answer. Anyway, 1.3. Of course, we didn't have to round to 4 decimal places, but this particular time. So this is quite interesting. I hope that helped you out on how to approximate that stuff. This is 3-1. So yeah, I think I've only got one problem on this, But you know, if you do this problem and understand it, you can do pretty much anything. Alright, any of these type of approximations where you just use the same process. Okay, well, we're over here at gotomath.com, and come on by and I might help you out. Just go up to the forum up there and leave me a message, alright?